In 12.3, we'll be discussing area and using trigonometry to help us find the area of different shapes. To start off with, we are going to look at the area of some regular polygons. And up until now, in order to find the area, well, let's just recall that the area of a regular polygon is area is 1/2 perimeter times apothem. And up until now, we needed at least two pieces of information to help us find the area. The perimeter, or at least a side length, and the apothem. There were a couple exceptions. If we had a square, a regular hexagon, or a regular triangle, we could use some other information to help us. If we were given the length of a side, we could find the apothem, or vice versa, and we could find the area. But with trigonometry, we are going to be able to find the area of any regular polygon, given only one piece of information. So in these problems that we're going to look at here, we're going to be given something about the perimeter, a side length, or the perimeter. We'll be able to use trigonometry to find the apothem, and then we can find the area. So I'll be doing number 1 and number 3 here, and then you can do 2 and 4. So looking at number 1, find the area of each figure, round your answer to the nearest tenth. We're going to end up needing a calculator here. So that's what I'm doing now. There we go. We don't need it quite yet, but now it will be there for when we need it. So we know area is 1/2 perimeter times apothem. Well, we see that this is a dodecagon. It's got 12 sides, and each side is 3 miles. So the perimeter is going to be equal to 3 times 12, which is 36 miles. Quite a large dodecagon. So our perimeter is 36 miles, so that's great. We have that value is 36, but we don't have the apothem right now. So that's what we need to find, and we're going to use trigonometry to find it. And so let's look at our center point here, and then we're going to draw in 2 radii of this polygon. Remember, radii go from the center to a vertex. And then we're also going to draw in the apothem, which I'll put here in green. The apothem is what we want to find. Now, I'm going to zoom in some so we can see this a little bit better. We know this is a dodecagon, so this is split into 12 equal triangles. I'm not going to draw all of them, but notice we'll have 12 of these triangles, which means we can take the entire 360 degrees divided by 12, which gives us 30. So each of these angles is 30 degrees, each of those central angles. Well, we actually don't want that full central angle for what we're working with. We just want this angle right here, so we can split that in half, and that is 15 degrees. So we know that's 15 degrees. Remember, we want to find the length of the apothem, which is this green. Now we know another piece of information because of the fact that we know each side length is 3 miles. We know that this length here has to be 3 miles split in half, so this is 1.5 miles. And now looking at that triangle, I'm going to outline it in black. We can find, so this is a right triangle, we can find the length of the apothem. So we think through this. We have the 15-degree angle. We know the apothem, which is the adjacent side, the adjacent leg, and we know the 1.5 miles, which is the opposite leg. So we have adjacent leg and opposite leg. So which trig ratio deals with adjacent and opposite? Is it sine? Is it cosine? Or is it tangent? And we see here it is tangent. So let's go ahead and find the apothem. So we have tangent. So we're taking a little break here so we can find the apothem to plug in there. So the tangent of 15 degrees equals the opposite leg, which is 1.5 in this case, over the adjacent leg, which is the apothem. That's what we want to find. We can multiply both sides by a, because we need that in the numerator. And tangent of 15, make sure our calculator is in degrees, and it is. So tangent of 15, so this is a times 0.2679 equals 1.5, and we'll divide both sides by that value. So we're going to divide by 0.2679, and then we can find the value of a. So 1.5 divided by 0.2679. So the apothem is 5.60 miles. Now that we know that, we can plug it back into our formula to find the area. So that was some side work that we had to do. Now we can plug in the 5.6. And so let's come down underneath our box here and find that area is 1/2. So that's 0.5 times 36 times 5.6. And we get 100.8 miles squared. It says round your answer to the nearest tenth, and that's what we did. So 100.8 miles squared. Coming down to number 4, same idea. Let's see what type of shape we have here. I'm going to count these. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 congruent sides. So it's a nonagon, 9 sides. Here, we're not given the side length, we're given the perimeter. Well, the perimeter is 72, and we want to divide that into 9 equal parts. 72 divided by 9 is 8, so 8 yards. Each length here is 8. I kind of jumped the gun there. We didn't necessarily need that quite yet, but we will. So we know area equals 1/2 perimeter times apothem. Well, we were given the perimeter. That's 72 yards. And the apothem we don't know, so we're going to need to find it. So we can draw in one of these triangles. Let's go ahead and draw this one here. And there are going to be 9 of these triangles, if you want to think about it that way. Well, the whole thing, whole 360 degrees, divided by 9 is going to be 40 degrees. So each of these triangles has a 40-degree angle, but that is not what we are concerned with. We actually need the apothem. So we're going to draw in the apothem here, which forms a right angle, and this angle is going to be 20 degrees. And since an entire side was 8 yards, the side we're working with here is going to be 4 yards. And once again, we can use that like we did last time to find the apothem. We have a 20-degree angle. We have the adjacent. The apothem is the adjacent leg, and the 4 yards is opposite. So we have adjacent and opposite again. That means we want to use tangent. So we'll do tangent of 20 equals opposite, which is 4, over adjacent, which is a. Multiply both sides by a. At the same time, I'll go ahead and type in tangent of 20. So this is 0.3640. Divide both sides by that. and we'll have the value of A. So 4 divided by 0.364 gives us 10.989. Well, that's going to actually round up to 11.0. So the apothem is 11.0 yards. And now that we know that, we can plug it in for the apothem value. And so we'll continue finding the area down here. Area is 1/2 72 times 11. So you could pretty easily multiply that out in your head. If you want to use your calculator, you can. It's going to be 0.5 times 72 times 11. 396 yards squared. So that's how you can find the area of any other regular polygon, and we can use trigonometry to help us out. We didn't have one in this section or in these examples, but you sometimes can be given the apothem